Xenobots, the world's first living robots. What if I told you these tiny machines are alive, and they can heal themselves, work together, even clean up our oceans, then vanish without a trace? Meet Xenobots, programmable living robots that might just change everything you know about life, machines, and the future. Years ago, biologists at Tufts University and computer scientists at the University of Vermont sat down with a bold question. Can we build a robot out of frog cells? They harvested skin and heart cells from African clawed frog embryos, then handed them to an evolutionary algorithm, an AI that bred thousands of digital designs, each tested in simulation for speed, durability, and self-repair. The winners became blueprints for real, living bots. It sounds like sci-fi, but in 2020, the team unveiled the first Xenobots, squishy, millimeter-wide clusters capable of movement, coordination, and healing wounds in a petri dish. How Xenobots work. 1. Building blocks. The secret lies in biological Lego. Frog skin cells form a flexible shell. Heart muscle cells act as tiny pumps that make limbs wiggle. Under the microscope, they look like blobs. Under AI guidance, they become swimmers, walkers, or shapeshifters. Here's the kicker. These aren't metal, plastic, or silicon. They're living tissue, meaning Xenobots feed off leftover nutrients in the dish. And if you slice one in half, it can heal itself, restoring its form in hours. Evolutionary design. Think of the AI like a coach for microscopic athletes. It tries random shapes. Some crawl forward faster. Others tumble or get stuck. Each generation breeds new designs, keeping the high performers. After thousands of rounds, you get a champion Xenobot. It's like Pokemon breeding. But instead of cute creatures, you get bio-robots, programming behavior. Xenobots have no brain. Their behavior emerges from the physical arrangement of cells. Place heart cells asymmetrically, and the bot swims in circles. Arrange them symmetrically, and it swims straight. It's pure morphology-driven programming. No code required. This flips our idea of robots upside down. No CPUs, no wires, just living cells organized precisely. Real-world implications. Beyond the wow factor, Xenobots hint at breakthroughs in medicine, ecology, and robotics. Medical microrobots. Imagine injections of Xenobots navigating your bloodstream to deliver drugs directly to tumors, then dissolving harmlessly once their job is done. No surgery, no long-term implants, just tiny healers. Environmental cleanup. Picture fleets of Xenobots roaming polluted waterways, gobbling up microplastics or toxins. They swarm like a biological army, then biodegrade when they finish cleaning, leaving no harmful residue. It's like hiring Pac-Man to eat plastic, except Pac-Man is alive and dissolves after lunch. Ethical and safety debate. Of course, living machines raise big questions. What if they mutate? Could they reproduce on their own? How do we ensure they don't disrupt ecosystems? The team strictly designed Xenobots to be unable to reproduce or survive outside controlled labs. But as biology and AI merge, our definitions of life and machine blur, and ethics must keep pace. We stand at the dawn of a new era where biology meets robotics. Xenobots challenge our ideas of what robots are and what life itself can be. In these tiny living machines, we glimpse future healers, cleaners, and explorers, crafted not in factories, but in petri dishes, guided by code. So the next time you think of robots, imagine something alive, something that breathes, heals, and if we choose wisely, leaves no trace but progress. If you're as fascinated as I am, hit that like button, subscribe for more mind-bending science stories, and tell me in the comments, would you trust a living robot inside your body? Let's spark the debate. Because the future isn't just mechanical, it's alive.